Good afternoon. I'm Jason from Argus, thank you. And we're excited to be here today as part of PPIM 2024. So to get started, I want to just give a quick overview of our next 30 minutes together. We're going to provide a high-level overview of some of the reasons to pig a pipeline, and then introduce some things that make pipelines unpiggable. Some of these may be obvious, like piping geometry or availability of infrastructure to send or receive, and some not so obvious. From there, Brett, who's my partner here today, Brett and I hope to provide an overview of some of the possible solutions through both pig design, innovative operational infrastructure, making once unpiggable pipelines or sections of pipelines piggable. In the end, of course, we hope to have 5 or 10 minutes for questions and look forward to that. But before that, I want to just touch a little bit on the motivation for our paper. Brett and I, either ourselves or our companies, have attended PPIM for countless years and started to notice a bit of a drop in unpiggable pipelines focused towards inspection, which is fine. But also in our day jobs, we're noticing more and more time our companies are spending educating people on reasons to pig and what is pigging. And so as the industry, that kind of tribal knowledge fades away, we thought we'd take an opportunity here to share some of our experience. So we hope, certainly through the paper and presentation, adds to be a good resource for industry education, and then also some of the technical references that we've cited in the paper I think will be useful for many applications. So you know a little bit about Brett and I. Brett is with Apache Products in Edmonton. Myself, I'm with Argus out of Edmonton. Not listed but mentioned is Alistair Blackley. Alistair is a co-author for our paper and instrumental in our presentation today, and is also with Argus as the manager of products engineering. So, why pig a pipeline? For many of you, this might be obvious, but for others in other areas of our industry, probably not so obvious. You know, certainly at this conference, the intensity of content on inspections is prevalent, so there's no doubt with that. I mean, in 2021, the Pipeline and Hazardous Materials Safety Administration, or PHMSA, along with the Department of Transportation, expanded the scope of safety and reporting requirements for more than 400,000 miles of previously unregulated gas gathering lines. That was through their final rule. So, you know, think about that, 400,000 miles of pipe on gathering lines, that's an incredibly large number. Fortunately, through technological innovation and advancements, both from an infrastructure standpoint, but also from a smart pigging or ILI standpoint, pigging of these once piggable lines is certainly possible. So acknowledging the importance of inspection and inline smart pigs, our discussion from here is going to focus a little heavier on the need and benefits of cleaning pigs or utility pigs. From an operations standpoint, pigging can promote production optimization, corrosion mitigation, and many other benefits. Our industry needs to pig across their piping networks. The reasons are plentiful, and we believe they cannot be ignored. So we're going to explore some of the more common reasons that piping and pipeline segments are unpiggable. These reasons can include, you know, features or components of the pipeline, even things as prolific reasons for not having the ability to send and receive pigs, so no launching or receiving infrastructure. From there, environmental considerations due to the venting or depressurization that's linked with pigging. After that, we want to talk about something a little less kind of the hit list there, and it's introduce the concept of economic feasibility when pigging. And what we're seeing is that the economic feasibility in itself for some applications is making otherwise piggable pipelines unpiggable. So at this point, I'm going to turn over to Brett, and he's going to walk through some varying aspects of the importance of pipeline design and geometry to ensure piggability.
Good afternoon, everybody. We very much appreciate you taking time out of your busy days to come out and spend some time with us this afternoon. Today we want to discuss what we feel is a very interesting topic, and that's un-piggable pipelines. I'll endeavor to walk you through some of the pipeline design elements that need to be considered when designing a pipeline pigging program. Diameter changes in pipelines can consist of wall thickness variations throughout the pipeline to account for under-the-road crossings. This can also be the case when steel and HDPE lines are fused at different intervals in the line. Pipelines can also consist of dual diameter line segments, which obviously pose a problem with pig selection and design. Having a pig too small will result in bypass and poor cleaning, with the pig getting hung up. Too large, the pig will get hung up and not be able to traverse the line at all. The smallest bend radius we usually encounter for pigging is 1.5D, but there are rare occasions when we have noted 1D bends are present, which would result in damage to most standard pigging designs or the pipeline. 1D pipe bends are typically limited to being pigged using spherical pigs, which have limit effectiveness, depending on the application. For a typical pigging program, when allowance for more flexibility with ILI tools is required, traditional guidance or industry norms would specify a minimum of 10D for small inch and smaller piping, 5D for 6 inch to 12 inch, and 3D for systems larger than 12 inch. When these tight radius bends are present, the length and geometry of suggested pigs need to be carefully considered. The visual on this slide is intended to illustrate an engineered 3D pipeline pig trying to traverse a 1.5D bend and the obvious issues that the pig will face trying to navigate and negotiate that bend. Various piping connections, including inlets and outlets, can also lead to geometry that can cause a pig to stall or become stuck, creating an unpiggable pipeline. Shown in the images is a spherical pig failing to navigate both a full-sized and reduced unbar T. As flow bypasses, the pig can easily become stalled or inadvertently go down a different outlet. This slide was added to showcase the pitfalls of improper pig selection as the foam pig is sucked into an unintended outlet. I'll pass it back to Jason and he can discuss existing infrastructure challenges that we may face. Jason?
So the need to pig pipelines that was historically not pigged arises from several factors. We've touched on some of them. The importance for regular maintenance, inspection, and cleaning of all pipeline types is more understood now. Couple that with increasing and new regulations aimed at reducing environmental impact of line breaks, venting, high-profile safety incidents, and the inspection required now for aging infrastructure. We can also factor in liquid condensate. Produced at the wellhead, this is increasingly growing in demand and value, and it's probably the value that's linked to the demand. The need to sweep these liquids within the pipeline has emerged and is growing. All of these changes and evolutions have resulted in the need for pigging lines that were never intended or designed for pigging. This requires operators to consider various alternatives to update or modify their existing infrastructure. We've established our industry requires more pigging, but how? Access to the inside of the pipeline is ultimately required to facilitate the insertion and subsequent removal of pipeline pigs. Traditionally, a conventional barrel-style pig launcher or receiver has been employed. So pipelines and piping systems previously not designed to be pigs generally don't have the provisions for such large infrastructure. As seen, these types of infrastructure require a sizable consideration. It's not only the space required to retrofit the line, but the upfront costs can be significant. Other considerations such as ease of operation, safety, site accessibility, and environmental impact are also required. Even with existing pigging infrastructure in place, other considerations surrounding environment and safety must be planned for. In some instances, these considerations alone can prevent pigging, even in a piggable line. The image on the slide was published by the EPA in one of their reports. In that report, they investigated emissions from pigging which were in violation of their Clean Air Act. In other instances, we've worked with end users who the proximity of their pigging location was a challenge. In one case, it was a sensitive environmental area, sour service, and in another case, strictly the close proximity to residences or farmhouses. In both those examples, it limits their ability to pig and certainly decreases the frequency of the pigging runs. So what about location? Can the remoteness of well sites and infrastructure make piggable lines unpiggable? Does cost feasibility make these same piggable pipelines now unpiggable? It certainly can. Let's consider a couple of examples. In the first one, a large Canadian gas gathering and processing company with facility in northeastern British Columbia, their liquids-rich media require pigging once a day. The challenge for them is their launching facility is remote. It's 3 hours away with no other pigging in that area. That's 3 hours one way. So you imagine the costs involved now to send that pig when you factor in labor of operators and personnel, trucks, overhead. Do you still send that pig? That seems maybe like an extreme example, but similar examples are very common. In the US, producers in the Bakken are pigging up to 5 or 7 times a day. They're doing this to manage their profuse liquids production. Imagine the costs needed to justify the feasibility of that pigging program. We'll look at another example on the next slide. In this case, challenging access is seasonal. In the wintertime in northern Alberta, road access to launch a pig is not in question. But in the summertime, the only access to well sites is by helicopter. In this image, the helicopter pilot is in fact the well operator. They would load pigs in the morning and then fly to as many of these remote locations as they could just to send pigs. In this example, again, the prolific liquids was too much for downstream processing facilities, so it required them to pig every second day. As you can imagine, the costs were excessive. What we're proposing is that even if your design features of the pipeline, which Brett has highlighted, are piggable and proper infrastructure is in place, meaning you can send and receive pigs, that there's still a challenge in piggable pipelines from a cost perspective. More innovative solutions are required. We've identified the problem, but how big is the problem? Is it actually a problem? And what we're trying to showcase here, and just before Brett takes us through some features which can be implemented to pigs to help convert unpiggable lines to piggable, we wanted to showcase some statistics to the problem. We heard a little bit about it today, and it was in and around these numbers. So we're saying it's hard to be entirely accurate with an estimate, but generally within the industry, it's agreed that 40% of the world's piping and pipeline infrastructure is currently unpiggable. So we're going to go back to Brett, and he's going to share some of the things you can do just with pig design to help traverse these pipeline challenges.
Thanks, Jason. Challenges are now behind us. It's time for some solutions. When setting up any new pigging integrity program, it should always start with a risk assessment that includes but not limited to capacity to manage debris, flow conditions, and proper pigging facilities for launching and receiving the pig, obviously. Many different pig designs or customization can be done as a pig manufacturer to combat the challenges presented in unpiggable pipelines. Some examples of this are butterfly discs, which provide more flexibility to navigate dual diameter lines, custom OD, ID, and thickness of all the sealing elements to specific applications, different brush options. Example is standard wire, pencil, nylon brush with varying trim lengths. Finally, overall lengths can be customized to navigate difficult piping features as well as to fit in various pig senders receivers, including multi-launchers and pigging valves. Diameter changes are very common challenges that can be solved with multi-diameter tools that can handle the changes in wall thicknesses present in a line as well as transitions from standard steel to HDPE as an example. Multi-diameter pigging can be a complex issue for pigging. Piping, can be a complex issue for pigging. Pig selection is key and requires an understanding of the pigging geometry, piping geometry. The image shows the same pig in both a large and small diameter section of the line. The discs that are sized to be for the larger section on the left will collapse through the diameter transition, using the smaller sized discs in a reduced section as shown on the right. We have two separate case studies listed in this slide that speaks to the challenges and successful completion of pigging runs involving a 34-inch to 36-inch transition in diameter. These pigs consisted of a combination of both 34 and 36-inch elements, as well as brushes to allow a tight seal in both diameters of the line. This was done with a company, Enbridge, out of Canada. Pig length, as mentioned previously, needs to be considered in the risk assessment process and ensure the pig always has a tight seal, even when navigating unbarred outlets. These durometer or hardnesses of the urethane pigs can be increased to provide an increased rigidity to traverse unbarred tees and more aggressive cleaning. Additionally, the durometer can be decreased in higher flexibility is desired, allowing for tighter bends or decreased pipe IDs. In the case of a steel mandrel pig, additional factors beyond urethane hardness need to be considered to ensure successful pig navigation. The figure on the left presents an engineered 3D tool trying to navigate a 1.5D bend versus the image on the right, which showcases a very similar pig with some slight modifications to the design, now allowing the pig to become a 1.5D tool and successfully traverse the 1.5D bend with no issue. Now Jason will speak to some of the operational solutions for unpiggable pipelines.
So listed on the slide is an overview of some of the operational considerations we've discussed that challenge operators to ensure pipelines are piggable. Now we're going to highlight a few of the solutions. The most common method within industry to send and receive pigs is the conventional pig launcher receiver. These have been around since really the beginning of pigging and have many pros and cons. This technology is presented today in our paper as both a challenge and a solution to making pipelines piggable. The large footprint makes modifications to existing unpiggable lines very challenging. The negative environmental impact associated with the technology is becoming an additional consideration and even a larger problem. As an alternative, pigging ball valves or pig valves, illustrated here, would be an alternative to conventional pig launchers and receivers. Though primarily used for cleaning pigs, innovative advancements in inline inspection tools with smart pig manufacturers have seen pigging valves now used to send and receive intelligent pigs. To date, there are several ILI pigging companies which have used pig valves to send and receive smart tools used for MFL, ultrasonic, eddy current when mapping is required, and of course leak detection. Within gathering networks, the need for extensive pigging facilities to send and receive ILI tools or cleaning pigs is significantly reduced or even eliminated entirely. As environmental sustainability and prominence gains, emissions reduction becomes critical in pigging operations. This involves minimizing the environmental impact of all pigging activity, updating infrastructure to reduce emissions associated with the launching and receiving of all types of pipeline pigs, and adhering to these emissions regulations to ensure responsible and sustainable pipeline maintenance. So we introduced cost feasibility as an obstacle, and two of the primary applications and arguments for this are challenges with the costs surrounding high-frequency pigging and liquids-rich applications, as well as remote access pigging. Wet gas production, or production of gas with significant condensates in North America has recently hit an all-time high. All forecasts are that this is going to increase, and the amount of piping with gas condensates is also going to increase. These natural gas condensates, when they fall out, accumulate in low-lying areas, such as river crossings, some road crossings, any low elevation piping. And with the accumulation of those liquids, you reduce the cross-sectional area of the pipe, effectively choking your flow of natural gas. These liquids have to be removed. As an operational solution to both challenges, automated and remote multiple pig launchers can prove to reduce costs associated with pigging considerably. Shown here is a typical spherical or ball pig automated launcher, which is configured to work remotely without operator intervention. Multiple pig launching significantly reduces pipeline emissions associated with pigging, as the barrel in this example is only vented once when you load the pigs, and not every time you pig, as in conventional barrels or launchers. As an alternative, and when operators are looking for enhanced cleaning capabilities and increased liquid sweeping effectiveness not achieved by spherical or ball pigs, alternatives such as the vertical Argus-style multiple pig launcher can launch urethane cup and disc pigs remotely. This technology enables the controlled and efficient pig launching while minimizing the need for extensive modifications to existing pipeline infrastructure. Automated multiple pig launchers provide additional solutions to operators challenged with the burden of remote or high-frequency pigging. Again, in this technology, you can load up to 11 pigs and then control them either automatically or manually from a remote location. No further human intervention is required. So let's reflect back to the example with the helicopter. In this case, the gathering network was almost unpiggable just due to cost, especially in the summertime. Multiple pigging systems offer significant gains through the reductions in associated operational costs, and then, of course, the decreased greenhouse gas emissions. So in closing, by understanding the complexities associated with pigging, pipeline operators and industry professionals can make informed decisions to effectively address the unique requirements of pigging previously unpiggable pipelines. This ensures the continued and safe transportation of vital fluids within our industry's infrastructure.